All right, today we are going to be learning a third way of solving systems of equations. And this third method is called the elimination method. And the goal on this method is that we are going to take the two equations and we are going to, through addition or subtraction, eliminate one of the variables. So that way we're left with an equation with only one variable, which we know how to solve. And so this is really going to be the most useful if both equations are written in standard form and when both equations have coefficients bigger than 1 in front of them. So if I were to try to do the substitution method, then I would be left with fractions in my equations, which remember we were trying to avoid with the substitution method because there would have been an easier way to do it. And that is today's lesson, the elimination method. So when you look at your system of equations, and you notice that you have a set where one of the variables has coefficients that are opposites of each other. So one's positive 4, the other's negative 4. Then this will be an example of where we would add the two equations together. So I'm going to go 7x plus, or 3x plus 4x, and I'm going to get 7x. And a positive 4 and a negative 4 just eliminated. That was the whole point. So now it equals 2 plus 12 is 14. And now I'm just solving for x. So x is 2. And then now we're back to what we're used to. We are going to substitute, and we can do it into either equation. So I'm going to do the first one. 3 times 2 plus 4y equals 2. So 6 plus 4y equals 2. 4y equals 2 minus 6 would be negative 4. Divide by 4, y would equal negative 1. And now I have my solution. I know that my x value is 2, and I know that my y value is negative 1. All right, so that's the first scenario. The second scenario is when I look, one of my variables, the coefficients are exactly the same. And if they're exactly the same, then I'm not going to add them together. I'm going to subtract. Now, here is where I want you to not just put a subtraction sign out in front. Because if kids make a silly mistake, it's that they remember to subtract on the first column. They'll sometimes remember to subtract the second column, but the time they make it to the third column, their brain is just auto defaulting back to addition, which is what it'll do if it doesn't think through it. So years of experience, if you take an extra second and put a subtraction sign on each column, now your brain is more likely to not make a silly mistake. So 7x minus 7x eliminated, that was my goal. So now I have 4 minus 2, so I get 2y equals 2 minus 8, I get negative 6. Divide by 2, y is negative 3. So now I'm going to substitute in. I'm going to substitute into the top one. So 7x plus 4 times negative 3 equals 2. 7x minus 12 equals 2. Add 12. 7x is 14. Divide by 7. X is 2. And now I have my solution. Remember, ordered pairs are x, y. So I'm going to put the 2, and then I'm going to put the negative 3. And there's the solution for that problem. All right, sometimes you're going to look and you're going to be like, either method works, because I've got one that if I were to subtract, my x's would eliminate, but I have a second option where if I were to add, my y's would eliminate. So you get to pick. It really doesn't matter on this one. I'm going to go ahead and just do addition. I like it better than subtraction. So x plus x is 2x, negative y and positive y eliminated, and then 1 plus 3 is 4. Divide by 2. X is 2. And then I'm just going to substitute in. I'm going to do the second one this time. X plus y equals 3. So I'm going to go 2 plus y equals 3. So y equals 1 after I subtract. And then I'm going to write my solution as 2, 1. Okay, so that is level 1, where a simple addition or subtraction makes one of the coefficients eliminate. So then the question is, well, Mrs. Stroll, what if I look and none of my coefficients are exactly the same and none of my coefficients are opposite? Well, then what do I do? And that is just one extra step. It means I'm going to have to multiply one or both equations so that I can make my coefficients match. So for example, I could, on this problem, I could say, okay, I want to make my coefficients match. So I could take this first equation, and if I were to just multiply this first equation by 4, now I would have 4x plus 40y equals 12. And then I would have my 4x plus 5y equals 5. And now I'm back to where I have matching, and I could just subtract to make everything eliminate. So now we're back to the front of the foldable. Or option 2, I could say, hey, I don't want to multiply the first one and eliminate x. What if I were to multiply this second one by 2? Then I would have 8x plus 10y equals 10. I would leave my first equation, x plus 10y equals 3. And now I would say, oh, well, now I can make those eliminate because I could subtract, and now my y's would eliminate. Now, I want to make sure that you understand. For this, you're not going to do both. You're going to get to make the decision. I want to make x eliminate, or I want to make y eliminate. That's a you get to choose. So looking at these, I'm going to go ahead and say, this one had smaller numbers, so let's go ahead and do this second one. So now I'm going to finish it out. 1 minus 8 would have been negative 7x. That would have eliminated. And 3 minus 10 would have been negative 7. Divide by negative 7. X would have been 1. And then I'm just going to go back, and I'm going to plug into my first equation right here. And I'm going to go 1 plus 10y equals 3. I am going to say 10y equals 2. So I'm going to say y is 1/5. And now I can write my solution as 1 and 1/5. That is where they intersect. This would definitely be one I wouldn't wanted to try to solve by graphing, because that would have been hard to determine where exactly it intersected. So that is an example of when I need to multiply one equation so that they match. And again, you're not going to do both options. You pick. I want to eliminate x or I want to eliminate y. Okay. Last scenario, what happens if multiplying one equation isn't going to make one of them eliminate? Well, then the second option is that you could multiply both the equations so that one of the letters eliminates. So on the first one, let's say, okay, my goal is to eliminate x. So option 1, I would multiply this first one by 2, and I would multiply this second equation by 3, because I'm trying to get x to eliminate. So now I'm going to have 6x minus 4y equals negative 14. And then I'll have 6x minus 15y equals 30. Okay, there was option 1. What if you would have said, oh no, I want to make the y's eliminate? Okay, so then we would have multiplied this first equation by 5, and we would have multiplied this second equation by 2. So 15x minus 10y equals negative 35, and 4x minus 10y equals 20. All right, so you would have picked, I'm going to do the red or I'm going to do the blue version. Last time we eliminated doing the second version, so let's go ahead and do the red version on this one. Okay, so now Mrs. Stroll has chosen to do this version. So I want to eliminate the x, so I'm going to subtract. So 6x minus 6x cancels out. Keep, change, that's going to give me 11y. Keep, change, that's going to give me negative 44. Divide by 11. Y is going to be negative 4. Okay, now I'm going to come back to one of the first original equations. I'm just going to do the top one. So I'm going to take this original equation, and I'm going to substitute in the negative 4. So 3x minus 2 times negative 4 for y equals negative 7. So 3x plus 8 equals negative 7. Subtract 8, 3x equals negative 15. Divide by 3, x equals negative 5. And so again, my final answer here would have been negative 5. And then my y value would have been negative 4. So they intersect at that point, negative 5, negative 4. And had I done the blue method, I would have gotten the same answer. I just would have found x first and then substituted in to find y. All right, that is the end of our elimination method notes.